Our galaxy is hiding a violent and bizarre past right under our noses. You are about to journey deep into the Milky Way to uncover 25 of its most astonishing secrets. We will explore a hidden graveyard of dead stars, reveal the truth about a cosmic cannibal, and confront the invisible force that holds everything together. By the end, you will see the familiar night sky as a place of profound and thrilling mystery. What is the colossal structure of fire and gas towering over the galaxy? And why does our solar system float inside a giant, empty bubble? The universe is far stranger than it appears. What single discovery about our galaxy would completely change your perspective on everything? That familiar band of stars in the night sky is a monument to ancient violence. Our Milky Way is a cannibal, a cosmic predator that has grown vast by consuming its smaller neighbors. This is not a metaphor. It is the violent history of our home, written in the motions of billions of stars. The first major clue to this galactic feeding frenzy arrived with data from the Gaia Space Observatory, which is mapping the precise positions and movements of over 1 billion stars. Astronomers noticed something bizarre. A vast population of stars was moving in highly elliptical, sausage-like orbits, diving straight through the galactic center. This structure, now known as the Gaia sausage, is the ghost of a dwarf galaxy that was torn apart and consumed by the Milky Way around 8 to 10 billion years ago. This colossal merger did not just add stars, it fundamentally reshaped our galaxy, potentially giving birth to the thick disk that characterizes the Milky Way's central bulge. But the feasting never stopped. Look toward the constellation Sagittarius, and you are looking directly at another victim being slowly devoured. The Sagittarius dwarf elliptical galaxy is a tiny companion currently in the process of being shredded by our galaxy's immense gravity. Telescopes have captured its stars being pulled into long, shimmering streams that wrap around the Milky Way like cosmic ribbons. These streams are the galaxy's digestive tract, the visible evidence of a meal in progress. Every time our galaxy consumes one of these smaller systems, it injects new stars, new gas, and a fresh burst of star formation, permanently altering its own composition and structure. So the next time you gaze up, remember you are not looking at a static picture. You are witnessing a dynamic, ever-changing ecosystem, a galaxy built from the remains of others. And this cosmic consumption raises a profound question about our own place in the universe. If our galaxy is a cannibal, what does that make the Sun, the Earth, and us? That same gravity which tears galaxies apart is also the force that holds our own together, but we are only just beginning to understand its true source. The Milky Way is not held together by the stars and gas we can see. It is bound by a ghost, a colossal and invisible presence that makes up over 90% of the galaxy's total mass. This is the secret halo of dark matter, an enigmatic substance that permeates every corner of our galaxy, yet remains utterly undetectable to our telescopes. The first compelling evidence for this phantom mass came from studying how stars orbit the galactic center. According to the laws of gravity, stars on the outer edges of a spiral galaxy, far from the central bulge, should move much more slowly than those closer in, just as Pluto orbits the Sun more sluggishly than Earth. But when astronomers measured these rotation curves, they found something astonishing. The outer stars were whipping around at nearly the same high speed as the inner ones. It was as if the entire galaxy was spinning like a solid plate. The only possible explanation was that the stars were embedded in a vast, massive sphere of something invisible, a halo of dark matter whose gravity was tugging on them, accelerating their orbits. This mysterious substance does not emit, absorb, or reflect any light, which is why we cannot see it. We only know it is there because of its immense gravitational pull, the cosmic glue that prevents our galaxy from flying apart. Without this invisible scaffolding, the Milky Way would simply unravel, its stars scattered into the void. So the galaxy we see, that breathtaking river of light across the night sky, is merely the glittering decoration on the surface of a much deeper and darker reality. This invisible dark matter halo is not the only ghost haunting our galaxy. At its very heart lies another, a sleeping giant with a violent past. Sagittarius A star, the supermassive black hole at the center of the Milky Way, appears quiet today, but it was not always this calm. Just a few million years ago, our galactic core was a blazing quasar, one of the most energetic phenomena in the universe. We see the echoes of this ancient cataclysm in two colossal structures that tower above and below the galactic plane, stretching for tens of thousands of light years. These are the Fermi Bubbles, vast balloons of superheated gas and cosmic rays, first spotted by the Fermi Gamma Ray Space Telescope. They are the lingering remnants of a titanic eruption, a time when Sagittarius A star was actively feeding on surrounding gas and dust. As matter spiraled into the black hole's voracious grip, it released a staggering amount of energy, firing two opposing jets of radiation and particles straight up and down out of the galaxy. This outburst was so powerful it punched through the galaxy's own gas, inflating these gigantic bubbles and flooding the Milky Way with lethal radiation. The evidence does not stop there. Observations from other telescopes have detected a faint, glowing fog of hot gas known as the Magellanic Stream, which trails behind our companion galaxies, the Large and Small Magellanic Cloud. This stream is being illuminated by the afterglow of that same quasar explosion, a cosmic flashbulb that went off long ago. For a brief period in cosmic terms, the center of our galaxy outshone all its stars combined, a beacon visible from across the universe. This forces us to reconsider our placid neighborhood. What would it have been like for any life in the galaxy during that violent era, bathed in that intense radiation? The fact that we exist at all suggests our solar system was either sheltered or very, very lucky. The quiet giant at the center is merely resting, and its past activity hints at a future that could once again be filled with fire. Yet this ancient eruption is not the only source of power near the galactic center. Lurking in the same chaotic neighborhood is an object even more bizarre, a cosmic engine known as the Great Annihilator. This is not a black hole's slow feast, but something far more violent and efficient. It is a point in space that unleashes titanic bursts of gamma rays, the most energetic form of light in the universe, and it does so with a strange, unpredictable rhythm. The source of this power is a fundamental clash of existence, a place where matter meets its opposite, antimatter, and both are utterly destroyed. When an electron meets a positron, its antimatter twin, they do not just explode. They vanish in a flash of pure energy, converted directly into two gamma-ray photons. Now imagine this process happening on an unimaginable scale, with rivers of particles and antiparticles colliding and annihilating continuously. That is the leading theory behind the Great Annihilator. It is likely a microquasar, a binary system where a dense stellar remnant, like a neutron star or a small black hole, is locked in a deadly dance with a normal star. The immense gravity of the dense object strips material from its companion, but instead of forming a neat disk, powerful magnetic fields funnel this stolen matter into two narrow, opposing jets that scream outward at nearly the speed of light. Within these focused beams, conditions are so extreme that pairs of particles and antiparticles are constantly created and then forced to collide, annihilating in a relentless storm of gamma radiation. This makes the Great Annihilator a natural particle accelerator of cosmic proportions, far more powerful than anything we could ever build on Earth. Its variability comes from the chaotic flow of matter from the donor star, a turbulent and clumpy river that causes the engine to sputter and roar. So while Sagittarius A star sleeps, this smaller, more frenetic object demonstrates a different kind of power, one born from the most complete transformation in physics. It is a permanent, localized inferno, proving that even on the fringes of a supermassive black hole's domain, the most extreme processes in the universe are still at work. These galactic geysers are a permanent and monumental feature of our sky, yet they are completely invisible to human eyes. Known as the Fermi Bubbles, these twin structures are colossal balloons of superheated gas and cosmic rays, each one towering 25,000 light-years above and below the galactic plane. If you could see them in gamma rays, they would dominate the heavens, appearing as vast, ghostly hourglasses centered on the Milky Way's core. Their discovery was a complete accident, a stunning revelation from data collected by the Fermi Gamma Ray Space Telescope. For years, this enormous structure went unnoticed, hidden in plain sight. The debate over their creation is one of the great astronomical mysteries of our time. One compelling theory points directly at the supermassive black hole, Sagittarius A star. This scenario suggests that millions of years ago, the black hole awoke from its slumber in a violent feeding frenzy. As enormous amounts of matter spiraled into its event horizon, the black hole could have fired off two opposing jets of relativistic particles, shooting them perpendicularly out of the galaxy. These jets would have acted like cosmic blowtorches, inflating the bubbles and filling them with their superheated contents. The other leading hypothesis points not to a single monstrous entity, but to the collective power of stars. In this version of events, the galactic center experienced a tremendous burst of star formation, a stellar baby boom. The most massive of these newborn stars would have lived fast and died young, exploding as supernova in a continuous, coordinated chain reaction. The combined energy of these countless stellar explosions could have blown a gigantic wind, carving out the bubbles and pushing the gas outward. Both theories have their merits, and both paint a picture of a galaxy with a far more violent and dynamic heart than we ever suspected. The Fermi Bubbles are not a static monument. They are a living fossil, a breath still held from a cataclysmic event that reshaped our galactic environment. They tell us that the quiet center we see today is a facade, and that the true history of the Milky Way is written in eruptions of almost unimaginable power. This wave of star birth is not a gentle, uniform swell, but a singular, undulating structure of almost unbelievable proportions. Known as the Radcliffe Wave, this is the largest coherent gas structure ever identified in our galaxy, a serpentine chain of stellar nurseries rippling through our own galactic neighborhood. For decades, astronomers pictured the spiral arms of the Milky Way as relatively smooth, consistent rivers of stars and gas. The Radcliffe Wave shatters that simple image. It is a colossal ripple within one of those arms, a wave 3 times longer than previously thought possible, stretching for nearly 9,000 light-years and billowing 500 light-years above and below the galactic plane. We are not merely near this structure, we are inside its territory. Our solar system actually orbits through it every 64 million years, surfing a gravitational wave made of the very stuff that creates stars. This discovery forces a complete rethinking of our local galactic architecture. The wave is not just a feature within a spiral arm, it might actually be the arm itself in our vicinity, a fundamental backbone for star formation. Within its crests and troughs lie the majority of the most famous stellar nurseries close to Earth, vast clouds of gas and dust like the Orion Nebula, which are even now collapsing under their own gravity to ignite new suns. This means the most iconic factories of new solar systems in our sky are all connected, all part of one single gigantic oscillation. The origin of this wave remains one of the most pressing mysteries. Did it form from the gravitational wake of a small galaxy that passed through our own, like a ship leaving a ripple on a cosmic sea? Or is it the result of some ancient, violent collision within the Milky Way? Whatever its source, the Radcliffe Wave reveals a galaxy that is not rigid and flat, but dynamic and three-dimensional, breathing with a rhythm that cradles the birth of new worlds. Even the empty space of our galaxy is not truly empty, but threaded through with an invisible force. A vast and complex magnetic field weaves between the stars, a ghostly web that influences nearly everything we see. This field is incredibly difficult to map as it does not emit any light of its own. Astronomers have to become cosmic detectives, studying the light from distant stars as it passes through clouds of interstellar dust. The tiny, needle-like dust grains align themselves with the magnetic field lines like countless microscopic compasses, and they polarize the starlight, giving it a specific orientation. By measuring this polarization across the sky, we can trace the field's invisible architecture. This magnetic personality is not just a passive presence. It acts as a cosmic regulator, shaping the paths of high-energy cosmic rays that constantly bombard the galaxy, and it provides a crucial scaffolding for star formation. The field's pressure can support vast clouds of gas against their own gravity, slowing their collapse. When a cloud does finally condense to form new stars, the magnetic field gets dragged in and twisted, channeling material into the newborn suns and potentially guiding the formation of their planetary systems. But the most startling magnetic secret lies at the very heart of the Milky Way. Recent observations have revealed a gigantic X-shaped structure embedded within the central bulge of the galaxy. This is not made of stars or gas, but of magnetic field lines themselves, a colossal imprint frozen in time. The leading theory for its formation points to a tremendously violent past. When our galaxy was young, its central bulge may have formed from a chaotic merger or a period of intense, unstable star formation. This turbulence would have churned the galaxy's core, stretching and folding the primordial magnetic field into this distinct, sharp-angled shape. The X structure is therefore a fossil, a relic of the galaxy's most tumultuous era, preserved for billions of years. It is a permanent reminder that the forces which built our galactic home were anything but gentle. While magnetic fields shape the galaxy from within, some stars achieve the ultimate escape velocity, breaking free from the Milky Way's gravitational grip entirely. These are the hypervelocity stars, lone projectiles hurtling through the void of intergalactic space at speeds so great they are on a one-way trip out of our galaxy. The first of these cosmic fugitives was discovered only in 2005, a blue star racing away from the galactic center at over 2 million miles per hour. To put that staggering speed into perspective, it is moving fast enough to travel from Earth to the Moon in just under 5 minutes. The most likely catapult for these stars is the supermassive black hole, Sagittarius A star, lurking at our galaxy's heart. Imagine a binary star system, two suns orbiting each other, drifting too close to that gravitational monster. The black hole's immense tidal forces can violently tear the pair apart. One star gets captured into a tight orbit around the black hole, while the other is flung away at an astronomical velocity like a stone from a sling. This gravitational slingshot effect can accelerate a star to well over the galaxy's escape velocity, dooming it to an eternal exile in the cold, dark vastness between galaxies. But the central black hole is not the only engine capable of such a feat. A different, equally violent mechanism can achieve the same result in the galactic suburbs. In a binary system where one star explodes as a supernova, the sudden, asymmetric detonation can act like a cosmic cannon. If the explosion is lopsided, it can kick the surviving companion star with such force that it too is ejected from the galaxy. These hypervelocity runaways tell a story of extreme gravitational encounters and stellar cataclysms. They are the unintended casualties of the most powerful events in the cosmos, cast out from their stellar families to journey alone through an unimaginable emptiness. What would the night sky look like from a planet orbiting such a star? It would be a view of profound isolation, with the Milky Way shrinking into a mere smudge of light behind you, growing fainter with every passing millennium until it vanished completely. Our galaxy's heart holds a secret rhythm, a slow and steady spin that is rewriting our understanding of its very structure. The central bar of the Milky Way, a dense collection of billions of stars stretching thousands of light years across the galactic core, is not rotating as quickly as we once believed. For a long time, astronomers assumed this gigantic stellar structure whirled at a rapid pace, but precise measurements from the Gaia spacecraft have revealed a surprising truth. Gaia has meticulously tracked the motions of over 1 billion stars, and by analyzing the subtle movements of stars within the bar itself, scientists could calculate its true rotational speed. The result was a shock. The bar is spinning more slowly than every major model had predicted. This sluggish rotation has profound implications, pointing directly to the invisible hand of dark matter. The speed at which the bar turns is governed by the total gravitational pull within the galaxy, a force dominated by the phantom halo of dark matter. A faster spin would suggest that dark matter is concentrated heavily in the inner galaxy, providing a strong central gravitational tug. The slower spin we actually observe means the dark matter must be distributed differently. It points to a model where the dark matter halo is larger and more spread out, its gravity more diffuse, resulting in a weaker pull on the bar and causing it to lag behind. This is like a giant merry-go-round. If all the weight is piled in the center, it spins easily and quickly. But if that weight is spread to the outer edges, the same push results in a much slower, more laborious rotation. The slow spin of the galactic bar is that same principle on a cosmic scale, telling us that the invisible skeleton of our galaxy is not tightly packed at its core, but is instead a vast and extended sphere of mystery, governing the dance of stars from the shadows. Beyond the brilliant stars we see lies a vast and hidden underworld. The Milky Way is littered with the dark corpses of dead stars, a galactic cemetery containing billions of stellar mass black holes and neutron stars. These are the final, compact remnants of the most massive suns after their spectacular supernova deaths. When such a star explodes, the detonation is rarely perfectly symmetrical. This cosmic imbalance acts like a rocket engine, giving the remaining core a powerful kick. This natal kick can launch the newborn black hole or neutron star at incredible speeds, sending it careening out of its stellar nursery and into the dark, empty spaces between the stars. Most of these objects are now completely invisible to our telescopes. A lone black hole, unless it is actively feeding on stray gas, emits nothing. A cold neutron star, having exhausted its rotational energy, becomes a faint, dark cinder. Astronomers estimate that our galaxy is home to a staggering population of these dark remnants. There could be as many as 100 million stellar mass black holes and over 1 billion neutron stars drifting unseen through the galactic void. This means that for every single shining star you see in the night sky, there are dozens of these invisible ghosts. They are the silent majority of our galaxy's stellar population, a hidden architecture of unimaginable density. Picture our solar system sailing through this darkness. We could, at this very moment, be passing within a few light years of one of these ancient remnants, completely unaware of its presence. It is a sobering thought. The glittering galaxy we admire is merely the surface, while beneath it lies a far more populous realm of the dead. Even our galaxy's own satellite system holds a secret. Among the known orbiting dwarf galaxies like the Large Magellanic Cloud, there might be another one hiding in the darkest shadows, a ghost satellite we have never directly seen. Astronomers call this hypothetical object Galaxy X. Its existence is not proven by light, but inferred from the subtle, rhythmic wobbles it imposes on the stars within our own Milky Way. Think of it like a detective feeling the vibrations in a floorboard to deduce the presence of a person in the next room, even with the door closed. In this case, the floorboards are the thin outer disk of our galaxy, and the vibrations are a distinct pattern of warping and rippling observed in the motions of certain stars, particularly a class of bright, pulsating stars known as Cepheid variables. These cepheids act as precise cosmic mile markers, and by tracking their movements, scientists detected a coherent disturbance, a gravitational tug that cannot be explained by any of the known galaxies orbiting our own. The only plausible source for this synchronized sway is the gravity of a concentrated mass, a dark dwarf galaxy. This proposed Galaxy X would be utterly dominated by dark matter, containing very few stars, which is why it has eluded every telescope survey to date. Its influence is purely gravitational, a phantom hand gently rocking the cradle of our galactic disk. This means the grand spiral we call home does not spin in perfect, undisturbed isolation. Its very structure is being subtly molded by an unseen companion, a silent partner in a cosmic dance that we can only sense by its gravitational footprints. This hidden graveyard of dead stars has directly shaped our immediate cosmic home. Our solar system is not drifting through a typical, dense region of the galaxy. Instead, we float inside a colossal cavity, a 1,000-light-year-wide void in the interstellar medium known as the local bubble. This is not an empty vacuum, but a region of incredibly hot, thin, and ionized gas, a superheated cavern surrounded by cooler, denser walls of neutral gas and dust. The discovery of this structure came from piecing together three-dimensional maps of our galactic neighborhood, revealing that nearly every young star within 500 light-years of Earth sits on the surface of this vast bubble. We are literally living inside a giant, spherical clearing in the cosmic forest. The origin of this bubble is a story of ancient chain reaction violence. Roughly 10 to 20 million years ago, a cluster of massive stars was born in this region of space. These stellar behemoths live fast and die young, and one after another they exploded as supernova. The shock waves from these successive cataclysms acted like a cosmic snowplow, sweeping up the surrounding gas and dust and pushing it outward, inflating the bubble and heating the interior to millions of degrees. Our Sun, during its orbit around the galaxy, simply wandered into this pre-existing cavity only about 5 million years ago. This environment has a profound effect on our cosmic neighborhood. The hot, thin gas inside the bubble influences how interstellar material can collapse to form new stars, and it even affects the number of high-energy cosmic rays that reach our solar system. The very space surrounding us is a fossil of a long-concluded stellar war, a testament to the fact that the violent deaths of stars are not just destructive, they are also creative forces, sculpting the galaxy and creating the rare, sheltered pockets where solar systems like our own can exist and evolve. Our journey through the galaxy is measured on a timescale almost beyond human comprehension. From our vantage point, the Sun appears to move through a static star field, but this is an illusion of our brief lives. In reality, our entire solar system is racing around the galactic center at nearly 500,000 miles per hour, completing one full circuit only once every 230 million years. This single circuit is known as one galactic year, and it reframes the entire history of our planet as a brief chapter in a much longer story. To grasp this scale, consider where Earth was the last time we were in this same position in the galaxy. It was the very beginning of the age of dinosaurs. The supercontinent Pangaea was just beginning to fracture, and the first small, nimble dinosaurs were emerging to inherit a world recently vacated by a mass extinction. Throughout their entire 160 million year reign, through the rise of the towering brachiosaurs and the fearsome Tyrannosaurus, the Sun never completed a single orbit. In fact, the Sun has completed less than 20 full orbits since the Milky Way itself first began to coalesce from primordial gas. This cosmic clock forces a humbling perspective. All of recorded human history, from the first cities to the present day, occupies a sliver of time so infinitesimally small it does not even register as a single heartbeat in the life of the galaxy. Our entire species has existed for less than the blink of an eye within a single galactic year. What will the Earth be like when we complete our current orbit another 230 million years from now? The galaxy will have spun on, largely unchanged, but our world will be utterly unrecognizable. Its fate written in the slow, silent rhythm of a cosmic dance we are only just beginning to understand. These drifting remnants of the dead are not the only ghosts haunting the void. The galaxy is filled with an even more numerous and elusive population of worlds, entire planets that have been torn from their suns and now wander the interstellar darkness alone. These are rogue planets, frozen worlds adrift in perpetual night, and their predicted numbers are almost incomprehensible. Current estimates suggest there could be billions, perhaps even trillions, of these nomadic worlds silently moving through the Milky Way, potentially outnumbering the stars themselves. Imagine an Earth ripped from the sun's warmth, its oceans freezing solid into a global glacier, its atmosphere collapsing into a thin frost on the surface. That is the fate of a rogue planet. How does a world become so utterly lost? Some are born alone, forming from tiny, collapsing clouds of gas and dust that were simply too small to ignite a star. But most are thought to be orphans, violently ejected from their home solar systems during the chaotic gravitational pinball of their youth, when multiple giant planets interact and fling the smallest one out into the deep. Detecting these dark, frozen worlds is one of astronomy's greatest challenges, since they emit no light of their own and float far from any illuminating star. Traditional telescope methods fail. The primary tool for finding them is a phenomenon called gravitational microlensing. When a rogue planet drifts precisely in front of a distant background star, its gravity acts as a tiny lens, bending and focusing the star's light for a brief period, causing it to momentarily brighten. This telltale flash, lasting only hours or days, is the planet's only signature. Each detection is a monumental achievement, a brief, ghostly signal in the immense dark. The existence of so many rogue planets forces us to expand our definition of a planetary system. Our own orderly solar system, with its planets on stable orbits, might be the exception rather than the rule. The galaxy could be a far lonelier place than we imagined, filled with countless frozen, solitary worlds on endless journeys through the cold, their surfaces sculpted not by sunlight, but by the faint glow of the distant stars they will never call home. Scattered among the billions of ordinary suns are stellar anomalies with atmospheres of pure strangeness. Some stars possess such bizarre and extreme chemical compositions that they defy our basic understanding of cosmic alchemy. The most famous of these is Przybylski's star, a stellar oddity whose light reveals a spectrum unlike any other. When astronomers break down its light into a chemical fingerprint, they find the signatures of elements that are utterly shocking. This star's atmosphere is laced with short-lived radioactive elements like promethium and actinium, substances that do not occur naturally on Earth because they decay into other elements in a matter of years. Finding them in a star is like walking into an ancient forest and finding a grove of trees still glowing from a nuclear blast that happened yesterday. It makes no sense. These elements should have vanished billions of years ago, yet here they are, shining brightly in the atmosphere of a distant sun. So what process could possibly be continuously manufacturing these fleeting, radioactive substances on the surface of a star? One leading theory points to a cosmic contaminant. Perhaps the star is being bombarded by debris from a nearby neutron star, an ultra-dense stellar corpse whose intense radiation could be transmuting the star's own atmosphere into these bizarre, heavy elements. As the neutron star orbits, it might be showering its companion with a rain of exotic nuclear material. But there is another, far more speculative idea. Some scientists have wondered if the peculiar signatures could be evidence of advanced technology, the nuclear waste of a Type II civilization, though most consider this an explanation of last resort. The prevailing mystery of Przybylski's star forces us to confront the limits of our knowledge. It suggests that there are nuclear processes occurring in the universe, perhaps in the intense magnetic fields of certain stars that we have not yet discovered or replicated here on Earth. These chemically peculiar stars are not just cosmic curiosities. They are natural laboratories testing the very edges of physics, hinting at a universe far more chemically complex and wonderfully weird than we ever dreamed. Our entire galaxy is caught in a cosmic current, being pulled toward a point in space we cannot even see. This immense and mysterious gravitational force is known as the Great Attractor, a region of space located in the direction of the constellation Centaurus, toward which the Milky Way and thousands of other galaxies are steadily flowing. Our journey toward it is not a gentle drift, but a movement at a staggering speed of over 1 million miles per hour. The source of this pull is a gravitational anomaly so powerful it dominates the motion of an entire supercluster of galaxies, a phenomenon that fundamentally challenges our understanding of the universe's large-scale structure. The greatest obstacle to solving this mystery lies directly in our own line of sight. The center of our Milky Way galaxy, with its dense clouds of gas and dust and countless brilliant stars, creates a brilliant band across the sky that we see as the Milky Way. But this same beautiful band acts as an impenetrable wall, blocking our view of the universe beyond. Astronomers call this the zone of avoidance, a region of the sky where optical telescopes are virtually blind, and it happens to lie directly between us and the Great Attractor. It is the ultimate cosmic irony that the center of our own home galaxy obscures the very thing that is pulling us. To peer through this galactic fog, scientists had to turn to other wavelengths of light. Radio, infrared, and X-ray telescopes can penetrate the dust, and by using these tools, they began to map the hidden landscape. What they found was not one single monstrous object, but an immense concentration of mass known as the Norma Cluster, a gigantic gathering of galaxies that forms the heart of the Great Attractor. Yet even this massive cluster does not seem to have enough gravity to account for the full strength of the pull we feel. The leading theory now suggests the Great Attractor is not the final destination, but merely a waypoint on a much longer and more profound journey. The true source of the tug may be something even more immense and distant, an incomprehensibly vast superstructure of galaxies known as the Shapley Attractor, the single largest concentration of mass in our observable universe. Our motion is likely the result of this combined gravitational pull, a cosmic river flowing from an area of relative emptiness toward the most densely packed region of the cosmic web. This reveals a universe where gravity's reach extends across hundreds of millions of light years, where entire galaxies are just leaves caught in a current flowing toward the largest mountains in existence. What does it mean for our future to be drawn so irrevocably toward a point we can only sense but never clearly see? This galactic recycling program is driven by the very explosions that tear stars apart. When a massive star reaches the end of its life and detonates as a supernova, the blast does more than just scatter heavy elements across space. It acts like a cosmic cannon, launching enormous clouds of superheated gas out of the thin galactic disk and high into the galactic halo. This ejected material soars tens of thousands of light years above and below the plane of the Milky Way, a scorching geyser of raw star fuel, but gravity is a patient force. As this hot gas travels through the halo, it gradually cools, condensing into massive, dark clouds of cold molecular hydrogen. Then it begins its long fall back home. This is the galactic fountain model, a continuous cycle where the galaxy breathes out fire and breathes in rain. This returning rain of cold gas is the primary fuel source for new rounds of star formation. Without this constant recycling, the raw materials needed to build new stars and planetary systems would remain locked in the thin disk, eventually becoming depleted or trapped in stellar corpses. The fountain ensures that the galaxy is a self-sustaining ecosystem. Picture a single atom of oxygen forged in the heart of a star, blown into the halo by its death throes, and then riding a cloud of cold gas back down millions of years later to become part of a new protoplanetary disk, and eventually perhaps the atmosphere of a new world. This cycle connects the violent death of one star to the gentle birth of another, a cosmic loop of creation that ensures the Milky Way remains a living, evolving entity. How many of the atoms in our own solar system once took this incredible journey high above the galaxy, riding the galactic winds before falling back to forge our sun and our planet? While the galactic center pulls our attention with its immense gravity, the exact opposite point in our sky holds secrets of its own. This is the galactic anticenter, the region directly opposite the bustling core, and it is far from the empty backwater we once imagined. Gazing toward the anticenter is like looking out the galaxy's back door, and the view is surprisingly crowded. Recent surveys have uncovered a complex tapestry of stellar streams arcing through this region, the tangled spaghetti of the galaxy's past. These are the ghostly arms of dwarf galaxies long since consumed, stretched into graceful, flowing ribbons by the Milky Way's relentless tides. Each stream is a fossilized timeline of a separate merger event, a celestial breadcrumb trail leading back to a smaller galaxy that was torn apart and woven into our own. But the true scale of the anticenter reveals an even bigger picture. It provides the clearest possible view of our galaxy's faint, extended halo, a vast and diffuse sphere of ancient stars and dark matter that envelops the entire luminous disk. This halo is not smooth and uniform. It is lumpy and structured, filled with the debris of countless collisions, challenging the idea that galaxies form from a single, calm collapse of gas. Instead, the chaotic halo points to a violent, hierarchical assembly, a galaxy built piece by piece over billions of years. The pristine view from the anticenter shows us that the Milky Way is not a finished product, but a living archaeological site, with the evidence of its growth still visible in the faint, swirling patterns of its outermost reaches. Even the grand spiral of the Milky Way has kept one of its major arms a secret from us. For centuries, our maps of the galaxy's structure were fundamentally incomplete, missing a colossal component simply because it was hiding on the far side of the galactic core, obscured by 27,000 light-years of gas, dust, and stars. This hidden limb is known as the outer Scutum Centaurus arm, and its discovery rewrote the blueprint of our home. The challenge was immense. Trying to see this arm with an optical telescope was like trying to see a mountain range through a dense, permanent fog bank. The central bulge of the galaxy, along with the intervening spiral arms, created an impenetrable wall. The breakthrough came from radio astronomy, which listens to the universe rather than just looking at it. Astronomers focused on clouds of cold molecular hydrogen gas, the raw material for new stars. These clouds naturally emit a faint radio signal at a very specific wavelength. By meticulously mapping the distribution of these hydrogen clouds, scientists could trace the skeleton of the galaxy's structure even through the cosmic murk. What they found was a stunning arc of star-forming material that perfectly mirrored the inner portion of the Scutum Centaurus arm, one of the galaxy's major spiral features. This confirmed that the arm did not end but continued on the far side, sweeping outward in a grand, symmetrical curve. The implication was profound. It meant the Milky Way was far more balanced and structured than we had assumed, a galaxy with a much more pronounced and elegant spiral form. This hidden arm is not just a minor appendage. It is a major architectural feature, a backbone of star formation that contributes significantly to the galaxy's overall mass and gravitational field. Its existence forces us to see our galactic home not as a lopsided collection of stars, but as a near-perfect four-armed spiral, a cosmic pinwheel whose full beauty was concealed in plain sight, waiting for the right technology to reveal its complete, majestic shape. Among the countless worlds in our galaxy, some are forged from the rarest of materials. An entire class of planets known as carbon planets could be composed largely of diamond and graphite. The most famous candidate is a scorched world called 55 Cancri E, a super-Earth orbiting perilously close to its sun. Under the intense heat and pressure within such a planet, carbon could crystallize into a layer of diamond hundreds of miles thick, creating a landscape of glittering mountains above a sea of molten graphite. This is not science fiction, but a plausible outcome of cosmic chemistry. These exotic worlds form around stars that are unusually rich in carbon, a fundamental building block of life as we know it, but here taking on a completely different role. In our own solar system, oxygen is more abundant than carbon, which is why our rocky planets like Earth are built from silicates, essentially sand and rock. But around a carbon star, the ratio flips. During planet formation, carbon atoms would seize the available oxygen to form carbon monoxide gas, leaving little oxygen behind to make rocky minerals. With carbon now the dominant element, it would condense into substances like carbides and, under the right pressures, pure diamond. The prevalence of these carbon worlds tells a profound story about the galaxy's diversity. It suggests that the very recipe for planet formation is not universal. A slight change in the chemical makeup of a stellar nursery can produce a planetary system utterly alien to our own, where mountains are made of gemstones and the very ground beneath your feet is a treasure beyond imagination. This discovery forces us to broaden our search for habitable worlds, reminding us that the galaxy is a place of infinite variety, capable of creating realities far stranger than any we could invent. Our position within the cosmos is far from typical. The Milky Way does not float in an average part of the universe, but sits inside a colossal emptiness known as the KBC void, a cosmic hole of staggering proportions. This void is a spherical region of space nearly 2 billion light-years across, an underdense bubble where the concentration of galaxies is significantly lower than the cosmic average. In fact, this local hole is about 7 times larger than a typical void, making our galactic neighborhood a genuine cosmic backwater. This discovery forces a radical rethinking of our place in the grand scheme. For decades, we have assumed we lived in a more or less average region, a fundamental principle in cosmology known as the Copernican principle. The existence of the KBC void challenges that very assumption. We are not at the center of the universe, but we do appear to be residing in one of its largest and most remarkable empty rooms. This local emptiness is not just a curious geographical fact. It has profound implications for one of the biggest mysteries in modern astronomy, the Hubble tension. This is the puzzling discrepancy between the measured rate of the universe's expansion using nearby objects and the rate predicted from the afterglow of the Big Bang. If we are living inside a giant void, the gravity here is weaker than in the densely packed regions outside. This means the space around us is expanding faster than the universe as a whole, because there is less gravitational pull from surrounding matter to slow it down. Our local measurements of the expansion rate, therefore, might be giving us an inflated, unrepresentative value. We could be mistaking the peculiar conditions of our own cosmic neighborhood for the behavior of the entire cosmos. It is like trying to measure the global climate by only standing in the middle of a vast desert. Your readings would be accurate for your location, but they would not reflect the average conditions of the entire planet. The KBC void suggests we have been doing something similar with the universe. This realization does not solve the Hubble tension, but it reframes the entire problem, forcing us to ask whether the tension is a flaw in our models of fundamental physics or simply a monumental error in our cosmic address. Our galaxy's elegant disk is not the flat, stable plateau we once pictured. The Milky Way is profoundly warped, its outer edges twisted upward on one side and downward on the other, like a giant vinyl record left too long in the sun. This immense distortion affects the farthest reaches of our galaxy, where the thin plane of stars and gas begins to curl, creating a shape reminiscent of a broad cosmic smile. For a long time, this warp was almost impossible to measure from our position within it, but a breakthrough came with a specific class of stars, the Cepheid variables. These are cosmic lighthouses, stars that pulse with a regular brightness that reveals their true distance with incredible precision. By mapping the three-dimensional positions of thousands of these Cepheids, astronomers could finally trace the true shape of the galactic disk, revealing its subtle but undeniable S-bend. The galaxy we call home is not a perfect flat spiral, but a gracefully warped structure slowly oscillating through space. So what immense force could twist an entire galaxy? The prime suspects are our own galactic companions. The most compelling theory points to the ongoing gravitational dance with the large and small Magellanic Clouds, the two most prominent dwarf galaxies orbiting the Milky Way. As they swing around our galaxy, their combined gravity, amplified by their own extensive halos of dark matter, tugs on the outer disk. This persistent off-center pull could easily torque the galaxy, setting the entire disk into a slow, wobbling rotation. Another possibility points to a more violent past, an ancient collision with a since-devoured satellite galaxy whose gravitational impact set the disk ringing like a bell, a vibration that has not yet dampened after billions of years. This warp is not a static deformity, but a dynamic, moving wave. Our solar system, located in the relatively flat inner region, rides this colossal ripple, entirely unaware of the vast, twisted shape our galaxy cuts through the intergalactic void. It forces us to ask, if our own galaxy is so easily bent by its neighbors, how many other seemingly stable spirals are actually warping and swaying in the darkness, their perfect forms an illusion of distance and time. The same magnetar that gave us a new galactic secret also delivered a moment of cosmic clarity. In April 2020, a star within our own galaxy flared with such violence that it was detected across 22,000 light-years of space. This was not a typical stellar outburst. For a few thousandths of a second, a magnetar known as SGR 1935+24 unleashed a colossal blast of radio waves, a fast radio burst originating from within the Milky Way for the very first time. These signals had baffled astronomers for over a decade, appearing as brilliant millisecond flashes of energy from galaxies billions of light-years away. Their source was a complete enigma, with theories ranging from colliding neutron stars to the energy beams of alien civilizations. The detection from our own backyard provided the first direct evidence, linking at least one type of FRB to the most magnetic objects in the universe. A magnetar is a neutron star born in a supernova, but with a magnetic field 1,000 trillion times stronger than Earth's. This field is so intense it stresses the star's solid crust, causing starquakes that can crack its surface. The leading theory suggests that these seismic events release immense amounts of stored magnetic energy, which then accelerates particles near the surface to nearly the speed of light. As these particles interact with the powerful magnetic field, they emit a coherent, lighthouse-like beam of radio waves in a single, brilliant pulse. This one event did not solve every mystery surrounding fast radio bursts. Some distant FRBs are repeating, while others are one-off events, suggesting multiple cosmic triggers may be at work. But it proved that the staggering energy required for these extragalactic flashes can be generated by a known, if extreme, type of dead star. The magnetar in our galaxy was a Rosetta Stone, translating one of the universe's most cryptic signals into a language of physics we can finally begin to understand. What other celestial powerhouses hidden in the far reaches of space are capable of such focused and furious bursts of creation? Our own galactic dance will one day end in a spectacular collision. The Milky Way is on an inescapable collision course with its nearest giant neighbor, the Andromeda Galaxy, a spiral even larger than our own. This is not a question of if, but when. In about 4.5 billion years, these two titans will begin their final, graceful approach. At first, the changes in our night sky would be subtle. Andromeda, which today appears as a faint, fuzzy smudge, would grow brighter and larger with each passing million years, swelling from a hazy patch into an undeniable celestial presence. As the galaxies draw nearer, their mutual gravity will begin to warp and distort their classic spiral arms, pulling long, shimmering streams of stars out into the void. The sky would fill with the light of a second, disintegrating galaxy, a view of cosmic chaos unfolding in slow motion. The actual merger will be a drawn-out and strangely gentle process. Despite the sheer number of stars involved, the vast emptiness of space means direct stellar collisions will be incredibly rare. The true violence will be gravitational. Stars will be flung from their orbits, cast into new, chaotic paths, or even ejected entirely into intergalactic space. The delicate structures of both galaxies will be utterly shredded over hundreds of millions of years. What will emerge from this billion-year-long celestial ballet is not a spiral, but a new, blended galaxy, an elliptical shape that astronomers have already named Andromeda. This new galaxy will be a featureless, football-shaped ellipsoid, its stellar population randomized, its beautiful spiral arms a distant memory. Our own sun will likely be thrown into a much wider, more chaotic orbit within this new entity. This future is written in the motions of the galaxies themselves, confirmed by precise Hubble Space Telescope measurements. The universe's expansion pulls most galaxies apart, but the local gravitational bond within our neighborhood is strong enough to overpower it, pulling Andromeda and the Milky Way together in a fateful embrace. This grand finale forces a profound perspective on time and existence. The entire history of life on Earth, from the first single cell to the rise of human civilization, has occurred in less than a single breath of this galactic year. We are living in the brief, quiet prologue of a story whose main event will not begin for billions of years, a story whose final chapter will see our cosmic home utterly transformed. These galactic fossils are the oldest known stars in the universe, drifting silently in the Milky Way's halo. Known as Population 2 stars, they are the pristine remnants of the cosmic dawn, formed when the galaxy itself was just a collection of collapsing gas clouds. Their existence offers us a direct line back to the universe's first moments, a living record of a time before the galaxy as we know it even existed. Unlike younger stars like our Sun, which are metal-rich and forged from the recycled debris of countless supernovae, these ancient suns are incredibly pure. Their atmospheres are almost entirely hydrogen and helium, with only the faintest traces of any heavier elements. This elemental simplicity is the key to their story. They condensed from primordial gas that had only been lightly seasoned by the very first generations of stars, massive and short-lived giants that lived and died in a frantic rush. When those first stars exploded, they seeded the void with the first heavy elements, the carbon, oxygen, and iron that would later build planets and life. The Population 2 stars are the second generation, carrying the faint chemical signature of that first apocalyptic wave of creation. By analyzing the precise chemical fingerprint of these stellar elders, astronomers can effectively read the recipe of the early cosmos. The minuscule amounts of elements like lithium found in their atmospheres match predictions from Big Bang nucleosynthesis, the process that forged the universe's first atomic nuclei in the initial fiery minutes. They are cosmic time capsules, preserving the conditions of the universe as it was just a few 100 million years after its birth. To study one of these stars is to look back more than 13 billion years to a time when the first starlight was just beginning to pierce the darkness. What stories could these ancient suns tell, having witnessed the assembly of our galaxy from its very first pieces? They are the silent patriarchs of the Milky Way, and their faint light holds the echo of the beginning of everything. Yet this grand galactic story has a final, unresolved chapter much closer to home. The outer darkness of our own solar system may be hiding a giant, a hypothetical world whose gravitational influence is the last great secret of our immediate cosmic neighborhood. Astronomers call it Planet 9, a potential ice giant up to 10 times the mass of Earth, orbiting so far from the Sun that a single year there could last 20,000 of our own. The evidence for this unseen world is written not in what we can see, but in the peculiar, clustered paths of small, icy bodies beyond Neptune in the distant Kuiper belt. These objects follow highly elliptical orbits that are strangely aligned, as if herded together by some immense, unseen force. Their orbits are tilted, grouped in a way that should not happen by random chance. The simplest explanation is the gravitational pull of a large, distant planet, a shepherd guiding its flock through the frozen void. Finding this ghost world is a monumental challenge. It would be incredibly faint, reflecting only the tiniest fraction of the Sun's distant light, and its orbit is so vast that astronomers have only a rough idea of where to look. The hunt involves some of the most powerful telescopes on Earth, like the Subaru telescope in Hawaii, which are meticulously scanning the predicted swaths of sky, looking for one slow-moving pixel of light against a backdrop of millions of stationary stars. This search connects our solar system directly to the broader dynamics of the galaxy. The very existence of such a distant planet raises a profound question about its origin. How did it get there? One compelling theory suggests that Planet 9 was not born in our solar system, but was captured by the Sun's gravity as it drifted through the galaxy, an interstellar orphan adopted by our star. This would mean our solar system is not a completely closed family, but an open system that can acquire new members from the galactic environment. The hunt for Planet 9 is more than a quest for a new world. It is a test of our understanding of gravity itself on the largest scales, and a reminder that even in our own celestial backyard, the most fundamental discoveries may still be waiting in the dark. This journey through 25 galactic secrets reveals a universe of profound and humbling complexity. Our home is a cannibal, a graveyard, a warped disk, and a structure of bubbles and waves, all governed by an invisible hand of dark matter. Each mystery we unravel seems to unveil two more, reminding us that the familiar Milky Way is a place of endless surprise. The greatest secret of all might be that we are only just beginning to learn its true story. So the next time you find yourself under a clear night sky, look up at that river of stars. See it not as a static picture, but as a living, breathing, and violently beautiful entity. Let us know which of these cosmic revelations changed your perspective the most. Share your thoughts in the comments below, and subscribe to continue this journey of discovery into the deepest wonders of the cosmos.